Welcome back to Advanced Skills Learning. When most people hear the term AI, they still picture a chatbot, a system that waits for a prompt, generates a response, and then stops. This interaction model is familiar, easy to demo, and often good enough for simple use cases. But it's also the reason many Gen AI systems feel impressive in isolation and frustrating when you try to use them for real work. Chatbots are fundamentally reactive systems. They don't have goals, they don't track progress, and they don't decide what to do next unless a human asks again. Even with large context windows, each prompt is treated as a fresh interaction. The model predicts text, but it doesn't manage tasks or outcomes over time. This is where AI agents change the picture. An AI agent is not just a model that talks, it's a system designed to pursue a goal by observing its environment, reasoning about what to do next, taking actions, and then repeating that loop. The key shift is intention. Agents are built to do, not just respond, so instead of waiting for prompts, an agent continuously decides what action to take next based on its current state and objective. The focus shifts from conversation to execution. At the core of every agent is a simple loop: observe, think, act, and repeat. The agent looks at its current state, plans the next step, executes an action, such as calling an API or querying a database, and then updates its understanding based on the result. This loop continues until the goal is reached or the task is stopped. In simple terms, the agent observes its environment or inputs, reasons about the next best step, takes an action such as calling a tool or fetching data, and then evaluates the result. That outcome feeds into the next cycle, allowing the agent to adapt as it goes. This loop is what separates agents from chatbots. A chatbot produces an answer and exits. An agent maintains state across steps. If the first attempt fails or returns incomplete information, the agent can try again, switch tools, or refine its approach. It can decide that the first answer wasn't sufficient, gather more information, retry with a different approach, or escalate to a different tool. This ability to iterate is what makes agents suitable for real workflows. Quick check, 2 seconds. What actually makes an AI agent different? Is it A. A larger context window, B. Tool access by itself, C. A goal-driven action loop? Keep your guess. The answer is C. Without a goal and a decision loop, tools and tokens alone don't create an agent. Architecturally, agents are usually built from 3 core components. The first is a planner or reasoning layer, often powered by an LLM, which decides what to do next. The second is memory, which can include short-term working context and long-term persistent state. This allows the agent to retain useful information across steps. The third is tools, the mechanisms that let the agent act on the task instead of just talking about it. This allows the concrete actions the agent can perform in the real world. Tools are what transform language models into operational systems to create a meaningful impact. Instead of merely describing how to query a database or call an API, an agent can actually do it. Instead of suggesting an action, it can execute it. This is why agents show up in automation, monitoring, analytics, and operational workflows. Without tools, an agent is still just a narrator. Memory is another subtle but critical distinction. Context windows are temporary and fragile. They disappear once the interaction ends. Memory is information the agent intentionally stores and retrieves across steps or sessions, enabling learning, continuity, and adaptation. This allows agents to stay consistent, avoid repeating mistakes, and build on previous outcomes instead of starting over. Without memory, agents quickly become brittle and repetitive. Importantly, not every system needs an agent. Agents shine when the scenarios are really complex. They make sense when tasks are multi-step, when decisions depend on earlier results, or when actions must be coordinated over time. Examples include troubleshooting workflows, multi-stage data analysis, autonomous monitoring, or systems that must decide when and how to use tools dynamically. But if your use case is simple question answering, summarization, or static retrieval, agents add unnecessary cost, latency, and complexity with little to no benefit. The extra reasoning loops can slow down the systems, introduce new risks, or add additional failure points without improving results. A good architecture means choosing the simplest system that works. Quick check, 2 seconds. When does an agent actually make sense? A. An FAQ chatbot. B. A single prompt summary. C. A multi-step task that uses tools and feedback. Keep your guess. The answer is C. Agents earn their complexity when iteration and decision-making matter. Let's wrap up with the key takeaways. AI agents are not smarter chatbots. They are systems that combine reasoning, memory, and tools to pursue goals autonomously. Used correctly, they unlock powerful workflows. Used blindly, they create fragile and expensive systems. The most important architectural insight is this: agents should be introduced deliberately, not by default. Use them when coordination, iteration, and action are required. Avoid them when a simple prompt or RAG pipeline will do the job more efficiently. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more GenAI explainers, practical architectures, and quick quizzes to test your understanding.